Okay, student. You know how the syndrome coding is used? So in syndrome coding, find syndrome matrix. If it is equal to 0, no error in the received code. So whatever the received code will be the transmitted code. So everything will be same. Okay. But syndrome matrix is not equal to 0, error in the received code. So whatever the syndrome matrix is showing, that value is in which particular row of H transpose matrix. See that particular row, and suppose let us say that is third row. So error is in the third bit. If it is a 0 in the third, then you can rectify it as 1. If it is 1 in the third bit, you can modify it into 0. Okay, because error is in the third bit or error in the second bit. But data bit length is only 3. But syndrome matrix is not equal to 0, and that value is in fourth row of H transpose. But fourth bit is nothing but a parity bit. Only 3 bits are the data bits. So there is no need to correct error in the parity bits. Okay. So error in the parity bit, maybe in the parity bit, but it not be in the message bits. So not a problem. There is no need to correct the parity bit. Yeah, whatever the information is transmitted, the same thing will be received. Okay. So in the similar way, now in this question, consider a 7,4 block code. 7,4 block code, n, k block code. Consider a 7,4 block code with parity equations P1 equal to D1 exclusive or D3 exclusive or D4. P2 equal to D1 exclusive or D2 exclusive or D3. P3 equal to D2 exclusive or D3 exclusive or D4. Determine generation matrix, determine parity check matrix. Determine generation matrix. What is the generation matrix? The generation matrix first part is identity matrix. Now this identity matrix order is ik cross k. So this is 4 by 4 matrix. 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. And the second part is parity. P1, P2, P3, because this is D1, D2, D3, D4. So now P1 is D1, D3, D4. D1, D3, D4. So 1, 0, 1, 1. Now P2 is D1, D2, D3. First 3 means 1, 1, 1, 0. P3 is last 3, D2, D3, D4. Last 3. 0, 1, 1, 1. 0, 1, 1. Okay, all are correct. Now this is parity. This is ik, k, and this is parity. So D1, D2, and this is D3 and D4. So this is generation matrix. Now what he is asking is parity check matrix. Now the parity check matrix, what is the parity check matrix H? The parity check matrix H, which is nothing but the parity check matrix H, which is nothing but the first part is P transpose and second part is in minus k. Now what is P transpose? 1, 1, 0, 0, 1, 1, 1, 1, 1, 1 0 1, and identity matrix I n minus k 7 minus 4 3 1 0 0 0 1 0 0 0. This is the parity check matrix. Now this is the parity check matrix, and this is parity check matrix. Then what is asking is determine error detection and error correction capability. Determine error detection and correction capability means then you want to do like this. Now this is 4 bits, D1, D2, D3, D4, like this. Therefore, how many possibilities? 2 power 4, 16, C1, C2, C3, and so on. C16, 0, 0, 0, 0, 2, 1, 1, 1, 1, like this. Okay. Now find all possibilities. Next, find P1, P2, P3. Now see here, code length is 7. In that, first 4 are data bits, remaining 3 are parity bits. Already parity equations are available. Now you can do like this and find Hamming distance. Now based on this Hamming distance, you can easily identify how many errors are corrected, how many errors are detected. Okay. Now based on the minimum Hamming distance, then you can easily identify T1 errors or T2 errors are corrected or detected. Okay, and you do this one also, and you decode these codes. Okay, you decode the receiving codes, and the receiving codes are similar procedure. Now first 4 are data bits, remaining 3 are parity bits. Okay, same syndrome decoding, S equal to R into, this is the received code, into H transpose. This is H is already available. Now this transpose. So syndrome matrix is equal to 0, no error in the received code. Syndrome matrix not equal to 0, error in the received code. Now syndrome matrix value is in which particular row of the H transpose. Now that particular bit position will be error, modified that particular bit. Now these are the 16 possible codes because 4 bits are the data bits. Now the parity bits is, the parity equations are available. Now based on that you follow this one and Hamming distance, and this is the procedure. Okay. do it this. Now here is one question. In a 7,4 block code, say in a 7,4 block code, the parity check matrix is this. Now this is the 7,4 block code. Parity check matrix is given. Now he is asking to find generation matrix and parity equations. Okay. So in parity check matrix, what is the first part? In parity check matrix, first part is P transpose and second part is In minus k, which is nothing but I7 minus 4, I3 by 3. So this is parity check matrix. But what is there in the generation matrix? In generation matrix, first part is identity matrix Ik by k. Ik by k is nothing but 4 by 4. 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. Now this is I k by k d1 d2 d3 d4. Now what is the second part? Parity matrix. But what is already available? Parity transpose is there. Therefore again you go for the transportation of this 1 0 1 1. This one 1 1 0 1 0 1 1 1. Now this is nothing but P1 P2 P3. Now that is a generation matrix. Now he is asking parity equations. So I want P1. What is a P1? Now see P1. Now in P1 where there is a 0, that is easy for you. Now this 0 means here only 0 combinations. Only 0 combination means D1, D3 and D4. Therefore D1 exclusive R, D3 exclusive R, D4. But is it correct or not? You can cross check with the remaining things also. 1 0 0 1 0 1 0 1 0 0 1 1. Matching. Remaining all are matching. Now P2, parity equation 2. Now where there is a 0, 0 means this one and this one. So first, second, last. First, second, last is 1. Okay. First, second, last is 1. First, second, last is 1. Matching. D1, D2, D4. Now P3. Now the last 3. D2 exclusive R, D3 exclusive R, D4. Therefore 0 exclusive R 0 0 1 1 1. This is the parity equations. Now this is the way you can correct the errors, and you know how many errors are detected, how many errors are correction. Okay. Now this is for binary ones and zeros. All these codes are now, which is nothing but information. But earlier, now we have the transmission of symbols. Okay. Now that is a generation of symbols with certain probabilities. So for that particular discrete sources also there is a codes for decoding. There is a techniques for decoding. Now that techniques we will see. Now let us assume first, before we start that, let us assume m naught is a transmitted symbol. This is the notation. Okay, m naught is a transmitted symbol. M naught and M1 are transmitted symbols. R0 and R1 are received symbols. M0 and M1 are transmitted symbols. R0 and R1 are received symbols. P of M0, probability that the symbol M0 is transmitted. Probability that P of M0, probability that transmitted symbol is M0. Now P of M1, probability that transmitted symbol is M1. You know all these things. Okay, M0, M1 is transmitted symbols. R0, R1 is received symbols. Now probability of the transmitted symbol is M0. Probability that the transmitted symbol is M1. Or you know M1 is transmitted, M2 is received, or M1 is transmitted, M0 is received, like that, all possibilities. Okay. So there are two techniques for this particular decoding. Now that is, one is MAP, maximum A means A, maximum A posteriori decoding, and another one is ML, maximum likelihood decoding. Now these are the two decoding techniques. One is MAP decoding, another one is ML, maximum likelihood decoding. Okay, one is maximum A posteriori decoding, another one is maximum likelihood decoding. Now here see the channel diagram. Now discrete channel. This is the direct channel. You know, when M0 is transmitted, R0 is received. When M1 is transmitted, R1 is received. Now this is nothing but probability of R0 is received when M0 is transmitted. Now this is nothing but probability of R1 is received when M1 is transmitted. Now which is nothing but probability of R1 is received when M0 is transmitted, probability of R0 is received when M1 is transmitted. Now this is the discrete source, okay, generating symbols, and this is received symbols. Now for decoding there are two techniques. One is MAP decoding, maximum A posteriori decoding, another one maximum likelihood decoding. Okay. Now we first note down this, then we will see the procedure of MAP and ML. Now see here, this is MAP decoding. Assume that the received symbol is R0. For getting R0, the received signal is R0. This is the condition, right? Now, when actually R0 is received, when M0 is transmitted, the probability of symbol transmitted is M0, and probability of symbol R0 is received when M0 is transmitted. This is the main one for the cause of R0. To receiving R0, then this should be the main one. And now we will take the secondary for getting R0. Now R0 is mainly due to M0 and R0 is due to M1 also, that is secondary. So probability of transmitted symbol is M1 and probability of received symbol is R0 when transmitted symbol is M1. Now this product may be greater than or this product is less than. If that product is greater than, then that R0 is decoded as R0 is decoded as M0, and if it is less than, this R0 is decoded as M1. Okay, error. Now this is for condition for R0. Now the condition for second one is, assume that the received symbol is R1. So this is nothing but this R1 is coming because of M1. First you write that, okay? P of M1, probability of transmitted symbol is M1, and probability of received symbol is R1 when transmitted symbol is M1, greater than or less than. Now probability of transmitted symbol is M0 and probability of received symbol is R1 when transmitted symbol is M0. That is secondary. Therefore this may be greater than or less than. If it is greater than, R1 is decoded as M1. R1 is decoded as M0. Now ML, maximum likelihood decoding. Now see here. Now in ML decoding, the symbols M0 and M1 are transmitting with equiprobable. Two symbols equiprobable means 1 by 2. Means now this is 1 by 2, this is 1 by 2, this is cancelled. That is the only difference. Okay. So which is nothing but of directly P of R0 by M0, which is greater than or less than P of R0 by M1. If it is greater than, R0 is decoded as M0. If it is less than, R0 is decoded as M1. Now the another case is P of R1 by M1, which is greater than or less than P of R0, P of R1 by M0. Greater than, R1 is decoded as M1, less than, R1 is decoded as M0. Now consider a channel diagram as shown in the figure below. Now this is the channel diagram which is given to you. Now this is the channel diagram which is given to you, and the symbols M0 is transmitted with a probability of 0.7 and the symbol M1 is transmitted with a probability of 0.3, and apply MAP and ML decoding, determine error probability in both the cases. Okay, apply ML and MAP decoding and determine the error probability. Is asking probability of error in both the cases. Now see here. Now P of M0 is 0.7 into P of R0 by M0 0.9. Now P of M1 0.3, P of R0 by M1 0.4. So which is nothing but 0.63, 0.12, which is greater than. So therefore, now this R0 is successfully decoded as M0. Now P of M1 0.3 into P of R1 by M1 0.6. Now P of M0 0.7, P of R1 by M0 0.1. Now which is nothing but 0.18, which is greater than 0.07. So which is also greater than. Therefore R1 is successfully decoded as M1. Now both are receiving perfect decoding. R0 is decoded as M0, R1 is decoded as M1. Therefore probability of receiving correctly, probability of receiving correctly, first I will check probability of receiving correctly, which is equal to P of M0 into P of R0 by M0 plus P of M1 into P of R1 by M1, which is equal to 0.7 into now 0.9 plus 0.3 into 0.6. Now which is nothing but probability of receiving correctly, which is 0.81. Now probability of receiving error, probability of receiving error is 1 minus probability of receiving correctly, which is nothing but 1 minus 0.81, which is equal to the probability of error, which is equal to 0.09. No, sorry, 0.19. So the probability of error in MAP decoding is 19%, right? So now what happened here? Now both are equiprobable, that is cancelled. So R0 by M0 is directly 0.9 and this is 0.4. So which is greater than. R0 is successfully decoded as M0. Now this is R1 by M1, which is 0.6, and R1 by M0, which is 0.1. Now which is greater than. So R1 is decoded as M1. So now what is the probability of receiving correctly here? The probability of receiving correctly, which is equal to P of M0 is 1 by 2 into P of R0 by M0 is 0.9 plus P of M1 is 1 by 2 into P of R1 by M1, which is equal to 0.6. Now which is equal to probability of receiving correctly here is 0.75, and probability of getting error, which is equal to 1 minus probability of receiving correctly 1 minus 0.75, which is equal to 0.25, 25%. Now, same question, but he is saying that consider a binary symmetric channel. Consider a binary symmetric channel with crossover probability of 1 by 8. You know, binary symmetric channel is a channel. Now, both channels are having same probability. Error probability is same for both the channels. So, but crossover probability is 1 by 8 means now this probability is 7 by 8. 7 by 8. Right? Now, binary symmetric channel error probability is same for both the channels. Okay. Now, with P of m naught is given as P of m naught is given as 9 by 10. P of m1 is given as 1 by 10. Now, same apply MAP and ML decoding, determine the probability of error. So, if it is MAP, now P of m naught, which is nothing but 9 by 10 into R naught by m naught is 7 by 8, and P of m1 1 by 10 into R naught by m1, R naught by m1, which is 1 by 8. Now 63 by 80 and 1 by 80. Okay. Now definitely this product is greater than this. R naught is greater than, R naught is decoded as m naught. Now here, now P of m1 is 1 by 10 and P of R1 by m1 is 7 by 8. So 7 by 80. And this one P of m naught is 9 by 10 into P of R1 by m naught, which is 1 by 8. So which is around, this is 9 by 80 and this is 7 by 80. So which means that then definitely this product is less than this. Therefore, now your R1 is not decoded as M1. It is wrong decoding. R1 is decoded as M0. So error. So this is nothing but error. Okay. So now probability of receiving correctly is nothing but, now see here, P of M0, which is, what is P of M0? P of M0, which is 9 by 10 into P of R0 by M0, 7 by 8. Okay. P of M1, but see here the probability of receiving R1 when transmitting is M1, but you are not receiving R1 when the transmitted symbol is M1, because this is the wrong decoding. This is R1 is not decoded as M1. If R1 is not decoded as M1, this probability is 0. Therefore, this into 0. Now this is nothing but this product is 0. Now this is not there. Therefore, probability of receiving correctly, which is nothing but 63 by 80, which is equal to probability of receiving correctly 0.7875. So probability of receiving error 1 minus 0.7875, which is equal to probability of receiving error is 0.2125. Now, in ML decoding, now R0 by M0, this is 7 by 8, R0 by M1, which is 1 by 8. So this is greater than R0 is decoded as M0 in ml. Now here R1 by M1, this is 7 by 8, R1 by M0, 1 by 8. Of course, this is also greater than. Now R1 is decoded as M1. So here probability of receiving correctly, then we should take. Now this is 1 by 2 into R0 by M0 is 7 by 8, 1 by 2 plus R1 by M1 is again 7 by 8. Now therefore this is nothing but 0.875 and probability of receiving error is nothing but 1 minus 0.875 this is probability of receiving error in ML and MAP decoding. Now you can extend this to any much, okay? But now here he is giving like this. Now there are three symbols M0, M1, M2. And when M0 is transmitted, R0 is received. When M0 is transmitted, when M1 is transmitted, R1 is received. When M2 is transmitted, R2 is received. This is the direct one, direct channel. And similarly, when M0 is transmitted, R1 is received with certain probability. When M0 is transmitted, R2 is received with certain probability. And when M1 is transmitted, R1 is received. When M1 is transmitted, R0 is received. When M1 is transmitted, R2 is received. Now similarly, when M2 is transmitted, R2 is received. When M2 is transmitted, R2 is received. When M2 is transmitted, R2 is received. When M2 is transmitted, R0 is received. When M2 is transmitted, R1 is received. Certain probability. Now these are the three symbols. Now three transmitted symbols, three received symbols. Therefore now the symbols are having with some probability P of M0, P of M1 and P of M2. Then he is asking MAP and ML decoding, the same procedure, okay, without. But the main product you compare with the remaining three products, okay. So now we'll take this problem with values. Now this is 0.6. So 0.3, 0.1. And this is 0.5, 0.1, 0.4. And this is 0.8, 0.1, 0.1. And with the symbols probability P of M0, which is 0.3, P of M1, which is 0.5, P of M2, which is 0.2. Now see here. Now what is MAP? In MAP, first you take the main product. What is the main product? P of M naught. P of M naught into P of R naught by M naught. Now which is nothing but 0.3 into P of R naught by M naught is 0.6. Now this is the main product. Okay, then you will take the remaining products. What are the remaining products? P of M1, P of R1 by M1. P of M1, P of R1 by M1. Now P of M1, which is P of M1 and P of R0 due to M1. So what is P of M1, which is 0.5 into, now R0 by M1, R0 by M1 is 0.1, which is equal to 0.05. Now P of M2, which is P of R2 by M2, which is equal to, what is P of M2? P of M2, which is 0.2 into P of R2 by M2. P of R2, sorry, we are talking about R0, right? P of R0 by M2. What is P of R0 by M2? P of R0 due to M2 is 0.1, which is equal to 0.02. Now you see here, I can easily explain here. (0.18) is greater than this, and 0.18 is greater than this one also. Okay. Now this product is greater than of these two, then definitely R0 is successfully decoded as M0. Okay, R0 is successfully decoded as M0. Now this is for R0 case. Now what about R1? R1 means same. What is R1? P of M1. R1 is nothing but P of M1 into P of R1 by M1. This is the main product. P of M1 is P of M1, probability of M1 is 0.5 into P of R1 by M1. 0.5 into P of R1 by M1. R1, P of M1 is R1 by M1 is 0.5, which is equal to 0.25. Now P of M0, P of R1 due to M0, which is equal to 0.3 into, now receiving R1 due to M0, receiving R1 due to M0 is 0.3, which is equal to 0.09. Now P of M2 and divided by P of R1 due to M2, which is nothing but M2 is 0.2 into R1 due to M2. R1, I want R1 due to M2. 0.1, therefore 0.02. Now therefore, now you see here, Now this product which is greater than this and this product which is also greater than this. Therefore, successfully R1 is decoded as M1. Now come to here, R0, R1, R2. Now P of M2 and divide by P of R2 by M2. Now which is nothing but P of M2 which is 0.2 into P of R2 by M2. P of M2 is 0.2. P of R2 by M2 is 0.8, which is nothing but 0.16. Now P of M1, now P of R2 due to M1, now which is nothing but P of M1 is 0.5 into R2 due to M1. R2 is due to M1 is 0.4, which is equal to 0.2. Now P of M2, M0, P of R2 by M0, which is nothing but, what is P of M0? 0.3 into R2 due to M0. R2 due to M0 is 0.1, 0.03. But now you see here, this one which is greater than this, okay, but this one here which is less than, which condition is failed. Therefore this is failed at here, this is failed at here in M1. Therefore this R2 is not decoded as M2, this R2 is decoded as M1. R2 is decoded as M1. Now this is the probability of receiving correctly. This is the probability of receiving correctly. What is the probability of receiving correctly? In probability of receiving correctly, which is nothing but P of M0 into P of R0 by M0 plus P of M1 into P of R1 by M1, P of M2 into P of R2 by M2. So probability of receiving correctly, which is equal to P of M0 is 0.3 into R0 by M0, which is 0.18 plus 0.5 into R1 by M1 is 0.5 plus 0.2 R2 by M2, which is equal to 0.8. But here this one is okay, but R2 is not due to M2, therefore this probability is 0. This is not getting, so therefore this is 0.3 into 0.18 plus 0.5 into 0.5 plus 0, this is 0. R0 by M0, this is 0.6. Now the probability of receiving correctly, which is equal to 0.43, and